My name is Zaki Manian. I'm the co-founder of Skuchain. Just preface, I strongly believe in private blockchains. I think that while I love magic internet money, and I have contributed lots of technology to magic internet money, there's a phenomenal startup opportunity in the deployment of these secure, on-demand, collaborative compute environments. And so what we've done at Skuchain is just one of them, and we're going to talk through how it works. So we are, as you would imagine from the giant set of shipping containers, we are a supply chain company. And what this is our sort of model world of the legacy supply chain. There are systems of record. They are siloed in all of these different organizations. There is a flow of goods, a flow of information, and a flow of money. All of these entities are communicating with each other in a sort of extremely dynamic way. They are also they communicate with each other in a dynamic way. They use technology, some of which predate the internet, but are getting the job done at trillions of dollars of scale. Why would we introduce something like the blockchain into this world? So our blockchain technology basically is we build what you could call a smart contracts governance platform. It's a contract governance platform for enterprises that are doing business with each other in sort of large-scale supply chains. So we view this opportunity as collaborative transactions. So at every stage of sort of producing goods, shipping goods, or buying goods, producing goods, and shipping goods, there are enormous numbers of touch points between a variety of different entities, from logistics companies, warehousing, procurement, banking. You have all of these touch point elements. Nobody set out to create this as a distributed digital system, but the natural evolution of it was to create one of the world's most complex distributed digital systems. And that system is frequently inconsistent. And so if you look at any large player in the supply chain, whether it's the trade finance groups and banks, where they have hundreds of people sitting in Hong Kong that look over documents, or the purchase order processing center for Flextronics in India, where you have hundreds of people who are simply sitting there and reconciling information between different systems, we've built a distributed digital system that has an enormous amount of inefficiency around it. And that inefficiency translates into an enormous amount of lost opportunity. So our system, which we are introducing into a number of large supply chains, we are doing pilot transactions of real goods, basically adds these features that can be obtained by basically adding what computer scientists would call view consistency to data. You have ERP system 1, you have ERP system 2. They send messages back and forth, but neither of them are ever really sure what is in your counterparty's system of record. The blockchain is an opportunity to build a system where that consistency is inherent and designed in at an architectural level. And so that's essentially what we have been deploying. But one of the things that we've learned from the cryptocurrency world is that building a network with efficiency doesn't actually get you very far. One of the things that I see a lot of startups struggling with, and Skuchain certainly struggled with for many years, is how do we create an economic incentive for people to join and participate in the network? Efficiency is great, but it typically only benefits one party in any given transaction. How do you create a shared benefit that all of the parties in the network will have to sort of figure out how to apportion with each other rather than transfer from one to another? So what our sort of collaborative order processing system does is it surfaces financing opportunities that the legacy system would basically miss because the legacy system is too slow. By the time the legacy system has figured out that a given transaction is financeable, the time window in which financing could have occurred is probably passed. And so instead, in our system, because a financier who is looking into the shared system of record between buyer, seller, and manufacturer is able to have sort of absolute certainty that what they see is also what all the other parties in the system see. They're able to make financing decisions on sort of a process and transactional basis. And so basically what we've found is that by surfacing finished goods inventory where there is already a purchase order, where there is already a long-term contract in place, you can take that inventory, set up a financing entity. That financing entity can buy inventory and essentially is lending money to the manufacturer and the seller on the terms that are basically the buyer's credit rating. And so when you look at a very large supply chain, frequently you have buyers that are investment grade, but they are supplied by companies in their supply chain that have significantly higher costs of capital in China, et cetera. And by having this investment vehicle, we are able to save, we are basically able to move 90 days of working capital from being sort of dead capital sitting on a boat to working capital that is in the hands of the seller to grow their business. So we have this Skuchain. IMT stands for Inventory Management Trading Company. This is basically the process. The IMT raises money from traditional funds. The contracts are assigned to Skuchain. So this uses our collaborative sort of supply chain platform. Then we track the entire transaction through the platform. And basically, when the platform then indicates that finished goods have been created and that they are in the warehouse, at that point, the IMT can buy those goods, title to the goods can be transferred to the financing vehicle, and the seller gets their working capital. So this is basically the difference between, in the legacy system, it takes the seller 105 days to get paid. In the blockchain managed inventory setting, you get the seller gets paid in 10 days. So this is who Skuchain does. We were very involved in sort of the world of banks adopting new trade finance technologies. It continues to be a hot area. We did the very first interbank, international, blockchain managed international trade transaction, 86 bales of cotton. We've been working with Filament and a number of other IoT startups to get an IoT working group off the ground. So we do a lot of collaboration. We sort of are potentially blockchain agnostic, but we sort of believe most strongly in what Hyperledger and Fabric are doing, the Fabric technology are doing. This is an example of how much I believe in it. This is me doing internal propaganda with the CEO of IBM. So that's who we are, and if we want to sort of dig into the private versus public blockchain or ask questions about our business model, I'd be happy to answer.
Anyone? So are you going to, obviously the supply chain is vast and so complex.
Yep.
There's other areas like product provenance, IoT, what you mentioned. Are you looking to kind of get into those areas as well down the road, or are you pretty specific to your product right now?
So there is an ocean to be boiled. Mm-hmm. But one of the things that we really like, why this model? Like we've explored provenance. We've done a huge number of provenance POCs. Provenance POCs are great. Mm-hmm. Like there is probably a business there, but basically what that business looks like is a serialization effort today at enterprise scale. It costs about $500 million, and it costs about $50 million a year to operate. Can a blockchain make a difference there? Maybe. I haven't done a POC that really tells me yet whether or not that is true. Here we create an economic incentive and an economic alignment that fundamentally just doesn't exist. Like, everybody would love to access this, but if you were to, because we do, right now what we do is we do the legacy process of how do you finance a transaction like this, and we do the blockchain process, and we do them in parallel because we have real money at risk. And the legacy process is incredibly painful and incredibly time consuming. And if we can get to the level of maturity where markets, financiers, large corporations can trust this blockchain layer as deeply as they trust the legacy process, there's an enormous amount of money that can be unlocked. And maybe that then becomes the catalyst for sort of widespread adoption of all these other things the blockchain can do in a supply chain.
Go ahead.
Yes. Not my business model, but like explaining it isn't my business model, but it's apparently what I do. So like, the public blockchains are this phenomenal technology for creating an internet scale ledger. What do we mean by internet scale? It means thousands, millions, billions of participants in the system, all maintaining one consistent view of the world. And what does that give you? That gives you cryptocurrencies. Because if I have a database that is consistent among millions or billions of people, if that database is a database of account values, then I get currency. It's magic. That's why I call it magic internet money. It's really cool. What private blockchains are is private blockchains are basically business process management tools. I've outlined a business process. There are many others. And in conventional business process management between systems of record is message-driven. And the problem with message-driven systems is if somebody drops a message or the message doesn't get translated from one system or another, it's very difficult to recover from that. Because sort of, if you're a computer science, you're like, a scientist, you're like, this is the classic distributed systems problem. So what we have is these settings that we've constructed out of this sort of blockchain technology, where you have strong sort of mathematical guarantees of consistency between systems of record. And I think that's an incredibly powerful process. So if you have a problem that requires value transfer between untrusted parties, you need a public blockchain. If you have a business process management problem that you are trying to create a new opportunity around, a private blockchain is going to be an incredibly powerful tool.
And the cryptocurrency exists to incentivize users to secure the network. Otherwise, there would be no incentive there. But if it's a permission system, you don't need that incentive because these permission parties already know each other.
You also get like 3 to 5 orders of magnitude more throughput, so 10,000 times more throughput. Permissioned.
This is permissioned. Yeah. Cool. Any other questions on? Yeah.
So I guess I come from a slightly more technical background. Similar question, though. I'm a longtime fan of Ethereum and Bitcoin, and
Yep.
I'm also in the IBM Futures program, so I've sat in many of these propaganda sessions about
Yep.
Hyperledger. But I'm interested to how you explain the value proposition of specifically a Hyperledger versus Ethereum. You touched on it with like the trust versus not trust, but
Okay.
Isn't not Ethereum capable of doing all the things that Hyperledger can do? Or is there a specific reason why you would recommend one over the other?
Yes, but the answer is super technical.
I can handle it. I can handle it.
The specific reason is Ethereum is fundamentally designed to run programs on strangers' computers. So if you fire up an Ethereum node, you are running software that is written by people you don't know, that is interacted by people you don't know on your computer. So if that software is malicious, terrible things can happen. And Ethereum is, so when IBM is interacting with their supply chain, you're not running software on strangers' computers. Fabric is designed basically to run software on computers where you know all the counterparties involved. And you can attribute who created the software, who interacted with it, et cetera. And while you can do a lot of sandboxing, et cetera, the security guarantees aren't as stringent. And what you get from that is the ability for Fabric to natively operate on the types of business data that we're all familiar with. JSON, XML, database formats, file formats, et cetera, that Ethereum really struggles with. In theory, you can all do this, you can do all the same things. In practice, for some kinds of problems, Fabric is a far better tool.
All right. I think that's it. We'll move on. Oh, one more.
Is that clear to me what the incentive structure is on the buyer side of it?
Yeah. So that's so Dell, the buyer, his number is the same in both models. So the buyer isn't paying anyone else. Like, how much would you like to have Dell debt, but at like 100 basis points better spread than what you could buy bonds from Dell? Like, that's basically what our proposition is. Our proposition is Dell is going to buy the stuff. The stuff is on a boat. Like, if you buy that stuff from the manufacturer, if the investor buys the stuff from the manufacturer before the boat arrives, Dell still pays now you in 60 days. But you were able to lend money to Dell at a far more attractive interest rate than you could from buying their bonds in the market.
All right, quick one.
So for the manufacturer, you're basically eliminating their sunk cost risk for the aspect of them having a locked-in buyer.
Yeah, so typically what happens when you're a large manufacturer is you get an order for 100,000 widgets that you're going to deliver over 6 months. You don't make 20,000 widgets a month. You make 100,000 widgets, and then you turn the factory floor over to something else. So a large number of those things that you have a locked-in purchase order for are going to sit in your warehouse for many days. That's an incredible investment opportunity, but only one that is real if you can actually do the due diligence in like a day rather than 30 days.